All right, I'm back. We're on page 5 of note 6 of Calc AB, Implicit Differentiation, it's just like some problems to do. So let's see if we can do it. So suppose we have the implicitly defined function x squared plus xy plus y squared equals 4. All right, so y is a function of x. You can tell that because the first problem says find dy dx. X is the independent variable, y is the dependent variable. And we want to find it in terms of x and y. So, I mean, I think that's just going to happen. I don't really know why that's there. So let's see. So the derivative of x squared is 2x plus product rule first. The derivative of the second is dy dx plus second derivative of the first, and then plus the derivative of y squared. So y is a function of x, so 2y, chain rule, dy dx equals derivative of constant is 0. Mess that up, you're going to regret it a lot. So I'm going to say dy dx is, I'm going to subtract y, well, I'm going to subtract 2x from both sides, subtract y from both sides, and then divide by what are the two coefficients of dy dx? It's x and plus 2y, so divide by x plus 2y. X plus 2y. It's got a nice symmetry to it, but I don't think there's anything we can really do with that. So let's look at the next part. For what relationship between x and y will the slope of the curve be 0? Okay, so what relationship between x and y? This is kind of interesting. So if the slope is 0, then dy dx will equal 0. If dy dx equals 0, that means that negative 2x minus y over x plus 2y equals 0. All right. So I can cross multiply out the denominator and just say that that means that negative 2x minus y should equal 0. But that means that y is equal to negative 2x. So I think that's it. That's the relationship. As long as this relationship holds true, the slope will be 0. The only potential problem there would be at 0, 0. Well, actually, no. I guess like anytime. You know what? I think that. Oh, you know what? We have to actually do the next part anyway. So find all the points on the curve at which the tangent line is horizontal. So the tangent line has to be horizontal. So I know that the tangent line will be horizontal when this relationship holds true. But that's like a line, right? So there's an infinite number of points on that. What else do I know needs to be true? Well, if you look up at the top, I also know that this needs to be true. So I have two equations in two unknowns. I can probably solve this. So let's see. We have x squared. I don't know if you can hear the thunder. It's a little crazy outside right now. Plus y squared equals 4. And y equals negative 2x. I'm just going to do substitution. So x squared minus 2x squared, because I replace y with negative 2x, plus 4x squared, because I replace y with negative 2x and then squared it, equals 4. So that means that 3x squareds equal 4. So I'm getting x squared is 4/3. So either x is 2 over root 3 or x is negative 2 over root 3. These are the answers that I'm getting. Like, I think they're right. All right, so if, now there's a thing there's a choice to be made. We need to solve for y. So I could take x equals 2 over root 3, and I could either substitute it into x squared plus xy plus y squared equals 4. Or I could substitute into y equals negative 2x. One of those is a better choice. Since both need to be satisfied, and y equals negative 2x is just a function, y is just a function of x, I'm going to use that one. I'm going to say that my ordered pair is going to be 2 over root 3 comma negative 4 over root 3. So that x value actually only goes with one y value. If I take that x value and plug it into the other relationship, I'll get a quadratic for y, potentially get two y values, one of which won't be on y equals negative 2x. So it's a kind of a waste of time is basically what I'm saying. And I'm going to do the same thing with this. So I'm going to take negative 2 root 3 and substitute. So I'm doing all my substitutions into this equation. So I take this and I plug it in, and I took this and I plugged it in. That's where I'm getting these values. 4 over root 3. Okay, so I don't know, seems good, I guess. Let's keep going. So all of this, by the way, predicated on the fact that I got the first part right, which like, maybe I didn't check enough in retrospect. So it was like the derivative of x squared is 2x, product rule first or the second plus second derivative of the first, and then 2y dy dx. Okay, subtract 2x, subtract y, divide by x plus 2y. I feel pretty good about it. I think this is okay. All right, for what relationship between x and y will the slope of the curve be undefined? So if the slope of the curve is undefined, that means that I'm basically dividing by 0. So what I'm going to do is I'm going to borrow this. And so I'm going to copy and paste. I'm going to use the fact that I'm actually on an iPad. So I copy and paste that down. Undefined would mean, so I would need x plus 2y to equal 0, which means I can do one of two things. I can say either x equals negative 2y or y is equal to negative x over 2. I'm going to use that one, but I'm using that because I think it's like the more common thing to do. So I'm using this, but it's just as valid to say that anytime that x is equal to negative 2y, you will get an undefined slope. But I'm doing this because I think that it's more common. That's basically why. All right, so now find all points on the curve at which the tangent line is vertical. So points on the curve where the tangent line is vertical. So this is actually basically the same problem. Now, you can, there's a choice, right? So I'm going to use x squared plus xy plus y squared equals 4. X squared plus xy plus y squared equals 4. That's one of my equations. I can either use y equals negative x over 2 and sub that in. I get fractions, it's kind of gross. Or I can use x equals negative 2y. And I'm going to choose to use that because it just makes the math a little easier. And basically, I'm avoiding fractions, which I'm not afraid of fractions, obviously. You know, who's afraid of fractions? But I'd rather not use them if I can avoid them. So I get 4y squared minus 2y squared plus y squared equals 4. You get some really interesting, nice symmetry on this. 2, so 3y squared. This feels familiar. So I'm getting y is equal to plus or minus 2 over root 3. That's very familiar. All right, so if y equals 2 over root 3, then x is equal to negative 4 over root 3. All right, so my ordered pair would be negative 4 over root 3. Don't screw this up. That would be terrible. That's one ordered pair. Am I highlighting those? I don't know. And then if y equals negative 2 over root 3, I probably should highlight them. Make it really clear what's going on. X would be 4 over root 3. This. So my ordered pair would be 4 over root 3, comma, negative 2 over root 3. Okay, so let's go with a little highlighter on this. This is 1 point. This is 1 point. So I'm saying that's where I think the slope of the tangent line is undefined. So I think vertical tangent lines at x equals plus or minus 4 over root 3. I think here, horizontal tangent lines, actually, I think the horizontal tangent lines are y equals plus or minus 4 over root 3. So let's do a little thing. The Inspire, it turns out, can graph this relation in one of two ways. We can either graph it as a relation. So I'm going to see, I don't know what the advantages or disadvantages might be of doing it either way. So let's do graph. And to get a relation, all you got to do is like delete, literally hit delete on that equal sign, and then go to option 6 for relation. And then we can put in exactly what we have, x squared plus x times y plus y squared equals 4. And we get this. All right, so now I'm going to graph, I'm going to go back to function mode, I think. Menu, option 3, function. I'm going to graph, what did I think? I'm graphing, what am I doing? Negative 4 over the square root of 3. Okay, and then 4 over the square root of 3. Looking good, right? Horizontal, sounds good. And then I'm going to graph So I'm going to change it to equation template line, vertical line. So -4 over square root of 3, and then +4 over the square root of 3. So look at that. That all seems like really good, right? We got vertical, we got horizontal. I think we did it, frankly. So what I'm going to do is go back to the notes, and I'm going to let you take a look at this, screenshot what you will, and then I will call it a video and maybe come back in the next one and do more. So we found our derivative implicitly, which you want to double or triple check because every other part is based on that. And if you get that wrong, disaster. We found the relationship between x and y when the curve has zero slope, a slope of 0. Then we have to solve a system. So this was the biggest part, I think. You want to take your value and substitute in the linear equation, because a linear equation, 1x has 1y. A quadratic, 1x could actually be matched up with 2y values. That would be an issue, because only one of them is valid because of the linear relationship. So always go with linear if you can to solve for like a missing value. Then we did basically the same problem again, except we needed undefined, so it was about the denominator being 0, and then we found our points, and we checked it. So I think we did a good job on that, and I think we should all come back in the next video and keep going. So I will see you then.